Hello everyone, my name is Apoorv Bapat. I welcome you all in ELEATION's ANSYS Basic to Professional Training Program. In session 3, we are going to cover theory of 1D meshing. So we'll start with a recap. In session 2, we have learned what is FEM, are FEA, FEM different, advantages of FEA and FEM, discretization of problem, why do we carry out meshing, what is degree of freedom, element shapes and its characteristics, 10 questions you should be able to answer. In today's session, we are going to learn theory of 1D meshing, 1D element shapes, when to use 1D element, about deformation, about axial stresses, about bending, difference between deformation, deflection and displacement, material properties like Young's modulus, Poisson's ratio and material density. Let's start with when to use 1D element. We use 1D element or 1D meshing when one of the dimension of any component or object is very large as compared to other two dimensions. Like in this case, the length of this rod element is 1000, whereas the other two dimensions, that is cross sections, are 10 and 5. So they are very less as compared to the length, so we can use 1D elements in these cases. Element shape is line. Additional data from the user is remaining two dimension, that is cross sectional area. Element types are rod, bar, beam, pipe, axis, etc. Practical applications where you can use 1D elements are long shafts, beams, pin joints, connection elements and so on. Now let's see what deformation means. Physical deformation can be calculated on and inside a part or an assembly. Fixed supports prevent deformations. Locations without a fixed support usually experience deformation relative to the original location. Deformations are calculated relative to the part or assembly's global coordinate system. ANSYS gives results of following deformation. Component deformations, that is directional deformation. This option gives deformation in individual axis, like you can find deformation either on x-axis or on y-axis or on z-axis. Deformed shape, that is total deformation vector. This option gives total deformation, means it gives average resultant deformation. Now we'll see difference between displacement, deflection and deformation. Displacement is the distance from which one node or element, beam, column, frame, etc. moved from its original location. The movement could be in form of beam deflection, but it could also be the result of entire object moving undistorted, like a box sliding on surface with friction. Displacement can both be measured in terms of distance or in terms of rotation. Deflection is the distance that an object bends, twists from its original position. It would generally assume that an object deflection does not include rigid movement of the object. Deformation. Deformation is the actual distortion that occurs to a structural member. We most commonly discuss elastic or plastic deformations. Elastic deformations are those deformations that when the load is removed will return to original undeflected shape. Plastic deformations are those that will remain even after the loading is removed. Because most structures are securely attached to their foundation, there is general no rigid body motion. The displacement and deflection are particularly similar concept. We would say the outliner is deformation. Displacement and deflections are generally measures of distance or ratio of that distance compared to meaningful value, such as member length, while deformation is what happened to member to cause displacement or deflection. Axial stress is force per unit area on a body that tends to cause it to change the shape. The formula for uniaxial normal stresses is stress is equals to force upon area, where sigma is stress, F is force, A is area. Bending stress. Bending is due to internal movement. Since movement can be resolved into a couple, the internal movement can be considered as compression force and tensile force. The compression force results in compressive stresses and tensile force in tensile stresses. Therefore, bending stresses is a combination of compressive and tensile stress due to internal movement. Since the stress across a beam section varies from compression to tension, there is a location at which stresses is equals to 0. This is called as neutral axis. For homogeneous beam, the neutral axis passes through its centroid. Sigma is equals to my by I, where sigma stands for bending stresses, m internal bending moment about the section's neutral axis, y is perpendicular distance from the neutral axis to the point on section, I the moment of inertia of the section area about the neutral axis. Material properties. Young's modulus, also known as elastic modulus, is a measure of stiffness of solid material. It is a mechanical property of linear elastic solid material. It defines the relationship between stress, force per unit area, and strain, proportional deformation in the material. Poisson's ratio, denoted by nu, is the signed ratio of transverse strain to axial strain. Nu is the amount of transverse expansion divided by the amount of axial compression. Material density, more often referred to simply as density, is a quantitative expression of the amount of mass contained per unit volume. Mass is a property of physical body. It is measure of an object's resistance to acceleration, a change in its state of motion when a net force is applied. It also determines the strength of its mutual gravitational acceleration to other bodies. The basic SI unit of mass is kilogram. Mass is not same as weight, even though mass is often determined by measuring the object's weight using spring scale rather than comparing it directly with known masses. An object on moon would weigh less than it does on Earth because of low gravity, but it would still have the same masses. This is because weight is force while mass is a property that along with gravity determines the strength of this force. So, thank you very much for attending session 3. In session 4, we are going to cover how to solve 1D beam problem subjected to tensile load in ANSYS workbench. If you have any queries or doubts, feel free to contact us via query@eleation.com, or you can visit www.eleation.com. Thank you.